Hello everybody, this is Michelle, W5NYV. Here's a link to my resume if you want to see my professional credentials. I'm here today to share a presentation with you. This is a proposal for a work in progress for an open source communications satellite. It's a HEO, or highly elliptical orbit, but most of this work applies to GEO as well. High orbit satellites from HEO to GEO are of great interest to all of us. Open Research Institute, where I spend a lot of volunteer time, has been very successful in laying down the regulatory groundwork to allow international collaboration, open source, and open process amateur satellite work. This is regulatory relief that we did not have before. There are two parts to this regulatory work. First, ITAR and EAR regulatory relief, with an advisory opinion on publishing on the internet. You can see a poster session about that work here at Ham Expo. Second, debris mitigation and orbit talks with the FCC. You can find a link to that work at our booth, and the ex parte filing is available directly from the FCC. What do these two things accomplish? First, that open source work and international collaboration are safe, sane, and documented. This work was completed in August of 2021. Second, that the FCC understands the orbits that amateurs are interested in. There are two that ORI discussed with the FCC. First, straight to graveyard, which puts a GEO spacecraft into disposal orbit directly. The mission plan must be done completely and carefully, and there is no automatic approval of a license, but the FCC understands what the community wants and has no objection to pursuing designs that use straight to graveyard. This is very good news. Second, modified HEO, such as the orbits in this proposal that we are talking about today. Modified HEO avoids the growing number of commercial LEO constellations by raising the perigee to 1,250 kilometers. This has advantages and disadvantages, which we'll be talking about. This work was completed in November of 2021. You can find it in the MVP folder in our regulatory repository. MVP stands for Minimum Viable Product. The paper discusses an amateur-centric approach to communication satellites given debris mitigation rules. These efforts took a lot of time, several teams of motivated and competent volunteers, and some amount of money. Funding for the legal work required for the ITAR and EAR work was provided by YASME Foundation and ARDC. Thompson & Burke, LLC was the law firm involved. The debris mitigation and orbit workshops involved a small amount of private funding, and ARRL provided support, including counsel. Thank you to everyone that was involved in these regulatory successes. The regulatory work sets the stage for the technical work. This current effort is based on a proposal from Jan King and a team of volunteers that helped him. It was presented in 2014 to AMSAT-NA. AMSAT did not follow up on it, and there is a story about why, but it's not my story to tell. The proposal surfaced a number of times in the open source amateur radio scene. I put it out to the ORI mailing list for discussion and potential adoption. The timing could not have been worse because it was the week that COVID-19 started shutting down things in the US back in 2020. In the summer of 2022, Mikio Muri of JAMSAT suggested that I try and find something to propose to JAMSAT for HEO, and I immediately thought of this proposal. I asked Jan King how he felt about updating it. He was all for it, so we started working on it and building a team. We've had 3 work sessions, all recorded and published for anyone to watch. We walked through the proposal and identified the areas that needed to be changed. A lot has happened in the years since the proposal was put together, but it was excellently done, and the basics have stood the test of time. This is a fully open source project that is open to any participant almost anywhere. The team is already international. JAMSAT members have given invaluable guidance for the updated design. Our goal is to produce the highest quality proposal possible. LibreSpace Foundation is in the loop, and their membership has been supportive and helpful. All AMSAT members are invited to participate, and several have signed on. There is a pledge of $50,000 from an individual donor if the proposal is accepted. If you can match this or want to contribute financially, then get in touch. All versions of all the slides are available in our repository. We will be going quickly over some of the slides today in order to focus on the areas of greatest progress and where we need the most help. This is a team effort. It's a great privilege to be able to present the work of so many people. ORI has a very flat organizational structure, which lets projects be projects and doesn't put a lot of impediments between the people and the planning. ORI has clearly defined participant and developer policies, a code of conduct, and a culture of keeping the focus on the project. This reduces overhead, increases diversity and inclusion, and helps produce a lot of good work that is made freely available to the general public at no cost. If you would like to see more of this in the world, please consider joining our leadership team. So let's get to the proposal. Items in red are action items. They are actively under revision. First, we have the mission objectives. In 2014, communications was still considered to be experimental. We have changed that to clearly state that the mission objective is to deploy a functional communications resource. The original proposal had 10 gigahertz and 24 gigahertz as the amateur communication frequencies. During the work sessions, it was requested that we consider QO 100 frequency plan in order to allow reuse of ground equipment. And we have an existing open source transponder design that uses 5 gigahertz and 10 gigahertz. So we are talking about prototyping a system here that uses as many of these frequencies as possible. With powerful FPGAs and a vibrant firmware and software scene, we have plenty of opportunity here to show innovative designs that leverage multiple microwave bands. Thank you to the several microwave societies in the US and in Europe that have already provided feedback, comment, and critique about multi-band transponder possibilities. So a full transponder would have 1, 2, 5, 10, and 24 gigahertz bands represented. Note the 0.5 meter dish requirement. This is from JAMSAT. Japanese operators have limited space to work with. This is a change from the original proposal, and it does affect the link budget. This mission demonstrates open source design work, and there is an opportunity for small scientific payloads. We will not select or propose experiments, but as you will see in the system block diagram, there will be interfaces for experiments. We defer the choice of experimental payloads to whoever accepts the proposal. There are so many good ideas for experiments, and other organizations will have informed opinions that we will want to support, and connections with experimenters that we simply do not have. We want to provide the widest opportunities for science, technology, art, and culture in space. Mission objectives continue with specific open source propulsion goals. We will show the ability of electric propulsion to carry out critical mission functions while not interfering with high-speed digital communications. Finally, this is something that we center in our work. We will promote international goodwill and amateur technical education through open source design and development. We do not believe in opaque or authoritarian methodologies. We believe that amateur radio should be inclusive and supportive, and that gatekeeping is for trolls. HEO missions have a past. Here are 4 missions that a lot of you may be very familiar with. Some of these were international and collaborative. It's past time to go back to space like this. Our community is fully capable of doing this. The challenges and resources and formats are different now, but we are up to the challenges, we have the resources, and we have mastered the formats. The next thing the proposal addresses is orbits. We will have a Japanese-centric orbit along with a North American one, and however many more we need. The big change from the original proposal is raising the altitude from 500 kilometers to 1,250 kilometers to avoid crossing over the orbital shells of the commercial constellations at low Earth orbit. This change comes from what we learned during the regulatory work with the United States Federal Communications Commission. There are at least 2 drawbacks to raising the altitude like this. First, desaturation of the reaction wheels is harder if you don't go down to something like 500 kilometers. So this is something that we need to quantify. Second, preliminary analysis shows that the delta V is higher. We have a result from an AMSAT DL volunteer that it's 3 times higher at 1250 than 500. So we will be using GMAT, or the General Mission Analysis tool from NASA, to specify the orbits and to produce the values needed. This is an open source software. It's high resolution and widely used. The US FCC is encouraging spacecraft to deorbit as soon as the mission is completed. This modified orbit may consume more fuel than the original proposed orbit. These 2 facts are not necessarily in conflict. A goal of ORI work is to get faster turnover in space for amateur missions so that we can build up a larger archive of proven designs instead of having one egg in one basket at a time. To be very clear, the FCC no longer really wants 25-year plans. They want missions that work hard for less time and then get out of the way. 5 to 7 years is the goal for this payload, with 10 years being a true stretch goal. We take the guidance from the FCC to heart and are working hard to enable as many payloads as possible, each with shorter mission times than in the past, and a much greater priority on deorbiting than were envisioned, say, in the 1980s. The payload is at least a 6U spacecraft, or 6 units. This is the 2014 physical configuration. There are some things that will change, such as the solar panel deployment style, and there will be a lot of sensor fusion and less mass, and we will move things around to where the engines are not right by the antennas. The spacecraft internal volume allocation is most likely going to change, but you can see the thinking from 2014 here. We really want to get the engines as far away from the antennas as we can, because even with the synchronization work that we're going to include, it still needs to be further away. This is the original functional block diagram, and it will be both heavily relied upon and revised. Here is the communications subsystem system block diagram. There are 4 parts to this. There's a digital board, there's a telemetry, tracking, and command board, or TTNC. It has a dedicated RF link, and there are at least 2 RF communications boards. Here we show a 5 gigahertz uplink and a 10 gigahertz downlink subsystem. Note the RF switches here. This is something that we want to prototype right away. These switches flip if the digital board dies, or they can be flipped on command. The entire thing is converted from a fancy digital regenerative repeater system into a straightforward what goes in is what comes out type of transponder. Okay, so why would we do this? Well, we want the communications resource to work regardless of the digital brains. It will negatively impact the link budget, and you will lose some functions like authentication and authorization, but you get something that can fail over instead of just fail. This is important to us because we are pragmatic about communications. If you want to be part of building this prototype, get in touch. Assumptions about CubeSat power systems have changed. This proposal will have a simplified 28-volt subsystem. Solar arrays will not be hinged the same way they were for the original proposal. We're looking at fold-outs on the long edge. The mass budget will change. Assumptions about mass per unit are now lower. Attitude control baseline is reaction wheel with off-the-shelf components. These need to be updated and the effect of a higher orbit very carefully modeled. By the time you are watching this, some of the work may have been done. The recording date for this talk was on the 1st of September. Here are the operating modes for the attitude control system. The original proposal used the IHU from Fox, but this will be updated. The Virago processor is the baseline, and there are several other choices, including RISC-V open-source space-qualified processors. The basic assumptions for what was called a regenerative microwave transponder are essentially the same. The addition of adaptive coding and modulation in the DVB-S2X protocol is especially useful on 24 gigahertz due to the effect of water in the atmosphere on this band. Access to the transponder was listed as contention-based, but we have a better scheme with authentication and authorization. That work is being presented this weekend by another ORI volunteer, so please check out the schedule. Also, all presentations will be on our YouTube account after the Ham Expo platform closes, about a month from now. A quick note, here is a diagram describing the token generation. This is a brief snapshot of the innovative work going into the uplink protocol. The forward error correction on the downlink and the uplink has been updated. The downlink is BCH plus LDPC, from DVB-S2 and S2X, and the uplink uses opulent voice with convolutional and GoLay encoding. High bitrate Opus codecs are used in the native digital uplink. 16 kilobits per second is what we're testing with, but Opus can go up to 500 kilobits per second. You will have excellent voice quality using our uplink, and data can be transmitted without having to switch to a clunky packet mode. This work is being developed for terrestrial use as well. If you are interested in helping make an open-source microwave band HT with excellent voice quality, then there's a team working on this, and you are welcome to join. We deserve excellent voice quality on Earth as well as in space. We'll be using an FPGA-based approach for the digital functions on the spacecraft. The reference design uses Xilinx 7000 chipsets and analog devices RFICs. You can access the development stations over the internet. All of the development hardware is in ORI's remote labs. There's a full Vivado license and a full MATLAB license with all the toolboxes. You saw a deep dive presentation on the downlink encoder about 6 months ago at the March 2022 Ham Expo presented by Andre Suado. We will need more people to help with integrating the reference design on flight hardware, so if this sounds exciting to you, then welcome aboard. We also have an ultra-scale dev board up and running for the next generation past what we're talking about here. If you want to help get polar codes on the air for deep space missions, we have your back. Power amplifier notes are here. This or a similar part is going to be the baseline. I'm going to skip over the link budgets for now for 2 reasons. First, we have an excellent link budget spreadsheet from Jan King, which has been recently renovated and expanded for our purposes. And we already know that enough has changed from when these budgets were done that they're no longer accurate. And I'm going to make an editorial note here about link budgets. They are aware items. If you're not familiar with a link budget, then here's the 20. A link budget is very similar to a financial budget. You have power that you can spend, and that power must create a signal that the receiver can hear. You have degrees of freedom that you can use to create more gain in the transmitter. What that transmitter throws up must be able to be received by the receiver. So it is like balancing your checkbook. But the thing that most people miss about link budgets is that actual hardware in real environments are pretty ugly and messy. Many link budgets are just too simple. Therefore, they are too conservative. Some link budgets, arguably the massive Excel spreadsheet from Jan King, are too complex for casual use. If you don't know the right answers to all the values in the spreadsheet, and for Jan's work there are a lot of values, then you can end up with an answer that's wildly wrong. Link budgets are truly accurate only when the system is complete and you can measure everything, backfill the link budget, and go, haha, look at that, it worked. So at this stage, we do have link budgets that show we're in the ballpark, that we can close the link, and that's good enough to put our backs into this and get it done. We will be using Jan King's extremely advanced link budget along the way, but it will be for documentation as much or more than as a predictive tool. We have the answer, we can close the link. It's up to us to get every last tenth of a dB out of the link because any increase is an increase in throughput. This is how real systems tend to be built. The link budget is an extremely valuable tool to get the most out of the design, and we're past the first hurdle here. The TT&C will probably not change much at all. This is an area where if it isn't broken, please don't try and fix it. There are a fraction of us that think in-band signaling should be attempted because it's much more elegant, but the burden of proof on reliability is pretty high. Here's more about TT&C. There's link budgets for the telemetry, tracking, and command as well. RADFX was proposed for this payload, but as explained earlier, for this proposal we are providing an interface for experiments, but not specifying them. Imagine if RADFX could have flown on this HEO if it had been accepted by AMSAT-NA. Pretty cool proposal. The one experiment we can do inherently is a precipitation attenuation study. And I'm really excited about this. Here's the original proposal, which involves a beacon. However, with adaptive coding and modulation in the downlink protocol, we may be able to report results simply by letting the protocol adapt to the channel, record what it does, and cross-reference this with meteorological data. There is a big opportunity here for sensor fusion, computer vision, and machine learning. This is essentially ambient science because the communication signals themselves provide valuable weather-related data. This makes transmitting on 24 gigahertz much more interesting as it allows us to see weather with our transponder. How cool is that? Here's the original design for the attenuation experiment. We think we can simplify this and also extract more data than originally envisioned. Now we come to the electric propulsion subsystem. ORI has the green light to develop an open source application of US patent number 10006445. This is a wonderful opportunity, and we are going to take full advantage of it. This vacuum arc thruster micropropulsion subsystem is an outgrowth of the GWU Micropropulsion and Nanotechnology Laboratory research. NASA Technology Readiness Level 8 flight hardware has been tested on orbit, on BrickSat, and Canaval. The engine will do 2 things. It'll raise the orbit and assist in disposal. A key part of this patent is synchronization of the motors, which reduces negative effects on broadband microwave communications. Electric motors create a lot of noise. We have a fundraiser going on right now to build engineering models and to retest the design. Here are some very early photos of the engine. And here is historical video of the engine's firing.
You want to just go ahead and actually...
the process.
Okay, basically this is going to be like an introduction session. This is a power supply, all right?
Power supply.
Which is set to channel, channel
12
2.
volts.
Yeah,
we
go
got
ahead.
15 volts.
Right.
So we're going to put labels on these to make sure if people are running it, they don't get these mixed up.
Okay.
It goes into our power board.
Okay.
Power board, this also gets powered by the 12 volts. So 12 volts, 12 volts. Then we come over here, which is coming from the, I guess, soon to be the phone, currently the computer.
Yeah, the phone is going to be over there. We're going to put labels on here.
We're going to put labels on everything.
Right, okay.
So this is a secondary protection unit of on-off switches for our units.
Okay.
And then once the signals start coming, we're going to flip them on.
Right.
And then from the phone or the computer is when we're going to start allowing them to fire.
And
over here,
these are the thrusters?
So we have 1, 2, and 3 channels.
Okay, and they're all coming from a common trigger source, as we can see with the big mass of wires that we have here. So effectively, we're going to be actually...
So they're all going to be simultaneously.
All right, let's come back.
Okay, so step 1, I believe, is power.
Okay, so power on.
Right. Okay, we're powering on.
Sure.
You get green lights.
And you get green lights on the power management board. All right.
And you got a green light here.
All right,
to make sure this whole board is working.
Okay.
With all these lights.
Okay.
Okay, step 2
and
now.
everything is powered off, so these guys are not lit
up yet.
Right, and they're going to be controlling the power to those thruster channels.
Yes.
Okay.
So next step, now that the computer currently has gotten power from our system, and
the menu has come up.
On.
All right.
So the menu's come up, and now we need to...
you need to define the frequency that you're going to be working on.
Define the frequency. So I'm going to click 1.
Okay, great. Go ahead.
Because I want 1 hertz.
Right, and that actually set it to a time delay of 99928.
Okay.
Pulse counts basically. That's fine. We'll translate that later. Go ahead, initiate the pulse by pressing the number 6 button.
I'm going to go to 6 on the keyboard.
Yeah.
Click 6.
There we go, and we can see the
pulse
train
coming up.
Well, we can see the indication of the pulse coming up.
Yes.
All right, go ahead. And then we're going to shift over. And
so shifting over, now we want to give power to our units now that we got the pulsing going. So I'm going to turn all 3 of them on at once. So we're going to go unit 1, which is this one.
Okay, let me just see the power. Go ahead. Okay, you've got green light for number 1.
So we have a green light for number 1.
This is just the logic, the L bus.
Yes, the L bus.
P15L, basically. Okay.
So we got 2 power coming on.
Hold on a second. Let me go back to this thing. So we're still drawing 0.19 or 0.18.
Okay.
All right, go ahead. Number 3.
You can't really see this. This is a different lid, but there's a green light in here showing that we're getting power.
Yeah, and we haven't closed the cover yet. So
yeah. So currently with our system, without the cover.
Sure.
There's your light. So currently with our system, we're getting a pulse to our low side, and we're also getting power to our low side. So now we're going to enable power.
Okay, for the first time, go ahead.
So I click little z or big Z?
Big Z is for enabled, big X for enabled. So Z is channel 1.
So we're going to do channel 1 first. Shift Z.
Yep, go.
Shift Z.
Enable channel 1.
So
and right away we hear this version.
Should be this top one. We're getting a little click.
And you actually did channel 1, 2, and 3.
1, 2, 3.
Oh, wow. It's like a red-green stoplight, right?
Yes, exactly.
So it's great. Okay, go ahead.
So now channel 2, we click Shift Y.
Yeah.
So Shift Y. It says enable channel 2. And we have 2 of them. The rest of them.
And my video is recording the two operating the sequence in air.
And now I do Shift X, correct?
Yep.
Shift X. 3 is pulsing or not pulsing?
It's pulsing. It is pulsing. You just can,
It's very, very light.
Right, but those are the adjustments that we have to do with the thruster.
Yes, that's an adjustment on.
I think the screw. I think the screw head needs to just Okay.
Be adjusted.
All right. Well, this is just the first trial. So you want to shut it off by just tell us what do you shut it off with?
Okay, so
There are some more recent videos of the hardware and a discussion, and that's in our YouTube channel. The original proposal had a total integrated dose experiment. This is a very low volume experiment. We are concerned about radiation, so we will very likely keep it. Here is a view of the expected interfaces. The double lines indicate redundancy. There is both a hardware and software heartbeat between the SDR board and the TT&C. This allows for different recovery modes. Here's the beginning of the RF plan expressed as a diagram. The entire scheme will be represented like this, as some of the assumptions about the RF chain had changed since 2014. Here is a walkthrough of some of the system architecture reasoning and decisions. Here's what's been reviewed. There is a system architecture document in the repository, and these are the slides that go with that work. So first we have the system block diagram. Here's some detailed callouts highlighting critical parts. Note we have splitters and bandpass filters here. The splitters work in concert with the switches in order to implement our failover mode. There will be losses and complexity associated with the extra parts required to pull this off. If the digital board fails, the switches activate and signals are routed around the digital board. Here's a very high-level estimate of the riskiest parts of the design, some similar designs that can be used as resources or references. This is the hardware states, which are defined as the RF switch states. We have 4 modes. There's a transponder mode, digital mode, transponder plus UHF telemetry, and digital mode plus UHF telemetry. Our SCR has preloaded files so it can operate as a beacon so that people can test their stations. The idea here is to roll through all the modulation and coding combinations in DVB-S2, S2X so that the station capability can be measured. The default digital downlink content will play when there is no traffic. You can see an example of this working as our terrestrial multimedia beacon project. We have a playlist for this part of the project on ORI's YouTube account. Here is a description and context for some of the requirements for interfaces. We think of the TT&C system as an intelligent router, and we know that the TT&C bus needs to be multi-master, hot swappable, and low power. There's a finite state machine involved with the collection of the telemetry. The heartbeat monitoring and fault recovery are also managed with the state machine. Here's the definition of the fault detection, isolation, and recovery. There's 3 sets of undesired effects and specific mitigation strategies. We aim for graceful degradation and not the elimination of all faults. The most frequently asked about extension is a camera. There are 2 options, and they are enumerated here with their advantages and disadvantages. We can put a camera on the digital board and have it interface to the SDR FPGA, or the camera can have its own TT&C bus interface. What other resources do we have? LibreSpace Foundation LibreCube project provides a baseline design for 1U cards. LibreSpace Foundation has given us a lot of support and welcomed us to their community. We are deeply appreciative of the friendship and advice they have given. ORI is a signatory to the LibreSpace Manifesto and fully supports LibreSpace Foundation's goals and purposes. Open Source Satellite Team is a source of advice and assistance. They have a highly competent team, make regular presentations, and have a deep commitment to education and inclusion. Open source is a wonderful way to advance the peaceful use of space. We have several commercial partners from radio and space industries. We have a variety of people at ORI that work in the space industry or have worked on amateur satellites in the past. A lot of us currently have circuits in orbit and are very excited to be working on this proposal and the hardware that will come out of it. What do we not have? Well, we don't have an experienced thermal design person, and we don't have a lot of mechanical engineers on staff. Our area of expertise is, in general, digital wireless communications and systems design. If you want to contribute in any area, you are welcome. Some areas need more help than others, and mechanical and thermal are the greatest needs. What happens next? Well, we push hard to complete this proposal to the best of our ability. All of this work will be done entirely in the open, and all work is published as it is created. We then present it to JAMSAT for review and judgment. If they accept it, we support JAMSAT's lead. The vision is to form a coalition of willing partners to build and launch multiple satellites using this design, using any of the orbits we've studied. Worst case, we have a publicly updated proposal for an amateur HEO satellite supported by a large array of engineering models and published designs. We firmly believe that our international amateur community is capable, fully capable, of accomplishing this design. We have never had a better time to do advanced digital communications work. We have solved some major regulatory roadblocks. We have accessible lab equipment and development stations. This equipment is available over the internet nearly 24 hours a day, 7 days a week, with technical support. We have a growing number of published designs, and the community wants to see this happen. It cannot happen without your interest, your reviews, your expertise, and your support. Want to join? Please click on Getting Started at openresearch.institute on the web. You do not have to be an expert to join. You just have to be willing to become more of one along the way. Thank you. Hello, everybody. This is Michelle, W5NYV.
Okay, there we go. Thank you very much, Michelle. That was fantastic, fascinating information. So can't wait to see this come together.
Yeah,
For everyone,
I'm with you. And thank you very much for moderating, and thank you so much to Eric for accepting the talk and being so supportive of open source and our efforts.
absolutely. And for everyone now, please submit your questions. There has to be plenty of great questions to come in, so we're waiting for them to show up here.
Since the talk was recorded, we've had the opportunity to present the proposal in its pretty much in the same state that you've seen it today at the JAMSAT monthly meeting, and the details will go into their journal, the JAMSAT journal, to solicit opinions and to get questions from their membership. So that process is moving forward. Very excited about that. We have a couple of extra slides from the propulsion team and further definition on the orbit. So all of that's in the repository.
Very good. Very, very good. And you mentioned there's many ways for others to get involved. We saw on the slide information. So that's a very key factor for anyone that has a high interest in this or even a moderate interest. Please jump in and join. I'm certain I can freely say this, that any and all help is well appreciated. So, chime in. I'm looking for questions still. We don't see anything coming in so far. Oh, here we have a question. We'll bring this one over from Michael, WH6ZZ. When are you hoping for the first launch?
Oh, that's a very good question. So Open Research Institute is a research institute. And so what we are looking for is organizations that do launches. The AMSAT is an obvious organization to go to really kind of take the lead and to do what they have experience doing. So we wish to build like a broad coalition with experts in getting launches. So when would I hope for first launch from the perspective of someone that works on the digital communications? Soon. I hope not too soon, because as you can see, there's plenty of things that need to be done, especially in the mechanical side. So I'm hoping as soon as possible, but if we were offered a launch 6 months from now, we would not be able to do very much on our own. So through the process of presenting the proposal, talking about it, developing teams to do the engineering work, we hope to show a steady ramp up to the point where we can start talking about schedule. If we were given a launch opportunity a year or two out, that would be aggressive, but we would be inclined to, with the right partners, to go ahead and go for it and to work towards that.
All right, very good. Can't wait for those. I can certainly speak for myself. Those of us that chase satellites periodically, we can't wait to have more things in the sky to play with. So
yeah, that's the goal. And the question, I answered it from the point of view of a standalone spacecraft. The designs that we're working on are very modular. So if we were included in another spacecraft, for instance, I think we would absolutely work towards that. So a little bit of more opportunistic attitude is something that we have. So any chance to get amateur radio active in space, we would pursue. So I just wanted to make that clear.
All right, very good. We have another question coming from Peter, G0ABI. Do you see that this would be a launch project between JAMSAT and other AMSATs around the world?
Yes, everyone is welcome. We are, since we were asked to think about a proposal to JAMSAT, that's where we started. But this is our hobby is international, and absolutely, I would love to see that become a launch project with multiple payloads between JAMSAT and all other AMSATs around the world. So an enthusiastic yes from me.
All right, very good. We have another question from Marcus, N5ZY. Sorry, I missed some content, went by very fast. This is not using traditional phone, but a digitized voice mode. With HEO, we would still need to track, right? They are not geo set.
Correct. We are preparing the design to be used for geo as well. So there are two orbits that we would like to keep in mind for all the requirements and specifications. So you're correct. A geo is less tracking. The disposal orbit or the straight to graveyard actually will drift around, and you will need to update where you point. And I think that is exciting. Actually, it gives you some variation. With HEO, yes, you will still need to track. While it's at a maximum altitude, it will appear to move slower. So it's not a case where the tracking demands are the same all the way around. But yes, you will need to track. Yes, it's digital voice is the native mode. So you are getting the lay of the land here. So no, it's not a default traditional phone.
Okay, and another question we have from Eric, WA6IGR. There seems to be a lower satellite community. Is there opportunities for collaboration?
Yes. One of the projects that we have at ORI is a respin of the Ambisat board. This project was originally targeting ISM bands, and the odds of it getting a license, in my opinion, are pretty low. So what we did is we took the Ambisat open source project and moved it to amateur 70 centimeter, more appropriate for space, we think. And that design, we're upgrading like the power of the processor, the power of the transmitter. So this is a LoRa-based system, and the sounding rocket test for that is coming up later this year. So yes, I would say there is opportunities for collaboration to include LoRa. It's not non-controversial in several aspects, but since we do have and are gaining more experience with LoRa space circuits, yeah, there is absolutely opportunities for collaboration.
Okay, and Marcus N5ZY has another great comment. HEO would be terrific for working DX. Absolutely. Look forward to that.
Strongly agree. It's interesting because some of the industry people, we have a wide variety of volunteers. Not all of them are hams, but they see the value of amateur radio and really kind of want to help. And many of them have gotten their license along the way. It's interesting because the perspective from some of the industry contributors to spacecraft HEO and GEO are, why HEO? They're like, that's why that orbit. You could have a better circular one, or why don't you concentrate on this or that? And it is news to them that the communications needs of amateur radio are not the same as commercial deployments. And it's been very interesting to kind of be able to explain and kind of let people in on how we communicate. In many ways, it's really fundamentally different from commercial deployments. So that's been one thing that I would not have guessed in advance, that our industry volunteers are coming at it from a different perspective.
Okay, and another comment from Michael, WH6ZZ. Molina orbit contemplated too?
Yes, I'm of the mind that we need to be as opportunistic as possible. If we were offered a launch for that orbit, and as long as there wasn't a reason that we couldn't take it, then I would. So if anybody has feedback about the orbits, to give us if we need a broader perspective, or if there's something that you think we need to consider like this, then that feedback, comment, and critique is very welcome. So yes, we've talked about this orbit, and we'd be open to it.
Okay, very good. I don't see any other questions. So please, anyone that has questions, please answer or drop a note in the chat here for us. I'd love to get your question answered right here while you have a wonderful opportunity with Michelle.
Something that I guess should not have surprised me was in the relatively short time between the proposal originally being written and given and now, is how much has changed in space within CubeSat, like the definitions or assumptions. And I know that those of us that are interested in technology, we kind of take it as an article of faith that things move really fast. But boy, you can get used to looking at things in a certain way. And when you really do a deep dive on a design, the design assumptions and the expressions of the design in just a few years can change quite a bit. So that was something that surprised me about going through this. And another thing that kind of surprised me was things that you may not consider to be things you may have considered to be settled technology have also had over the years have had some surprisingly good innovation. One of the things that personally surprised me was, wow, the solar panels are a whole lot better than they used to be. And for the longest, I remember, solar panels, they're only so efficient, they're settled, stable tech. No, not at all. So it's just been kind of delightful, and at times it can feel a little bit. You take a step back and you go, well, if my assumptions and rubrics and baseline, my baseline assumptions need to change in this area, then you start looking around. On the software side, there's been tremendous change. We have whole different philosophies about doing embedded software. In the case of space, though, so your software absolutely has to be reliable, and the best practices there do tend to be perceived as slowing things down and making them, there's a resistance to innovation. But we are seeing a real triumph of open source design in producing reliable, space-worthy, space-tested designs. It's been a big change since 2014.
Indeed. Very big moving target, no doubt. And Peter has a great comment here, G0ABI. Never give up, never surrender, Michelle.
Thank you. You've made my day, possibly my week. Thank you so much.
We have another question from Ron. In R50N, several amateur satellite launches have been delayed. In between that and supply chain disruption, what is the latest you're hoping to be on orbit by?
Well, the latest, as like Peter said, I'm just simply not going to give up, and we'll keep working as long as it takes. So I don't know what the latest is. That you're exactly right. The supply chain challenges over the past 3 years, to say it's a disruption is understating it. It's been pretty bad, especially with large parts like FPGAs. So I know this is probably going to come as a shock that I'm a raging optimist. And I've just been operating as if, you know what, it's going to get better. And the supply chain and delays and stuff like that. It'll be bad until it's suddenly not. And then we'll see rapid improvements. Okay, so that's from the perspective of a raging optimist. Being a little bit more realistic, I have no idea how long some of these very significant and, honestly, really preventive supply chain problems will continue. We have been lucky. I say lucky. We have a really remarkable volunteer community, and the things that we've been able to demonstrate in many cases have been because people opened up their drawers and cabinets and boxes, and okay, well, I have 12 of these parts, or I have 4 or 7 of these processors that are not available anymore, and I'm totally happy to use them to go ahead and develop engineering models. So the progress that we've made has been because the development stations for the large FPGAs were purchased right before COVID and put on the air, so to speak. We've been able to work with those as long as people are willing to remote in to do FPGA work, which is challenging, even with support like we offer. It's still easier to do things at your desk, and we know that. So the FPGA software side hasn't had as much impediments as the building hardware. But in many cases, we've been able to build and demonstrate hardware because people have very generously shared what they have for the purpose of the project. And it's only thanks to things like that we've been able to make the progress we have. So it's going to continue to be challenged. And yeah, the launch delays, there are a variety of reasons, and so I don't really know. As soon as possible, but not too soon.
That's a good, safe answer, as we're all trying to drive through all of those challenges. Greg has a question in C7B. What is the best URL to learn more about the technical details, to learn more about volunteering?
Oh, thank you so much. So the technical details, if you want to go straight to the GitHub repository, that is linked off of our Getting Started page on our website. So if you want to get a direct link to that, I believe we have it in both the Kuma Space Lounge, and also we have a booth in the VFairs hall, and you can click on that and it takes you straight to the website. So it's openresearch.institute and then Getting Started. And that will tell you how to get onto the mailing list, which is mainly for announcements, but also for discussion. It will tell you how to get into our Slack, which is where all the daily engineering, fairly high volume happens. And then the link to the GitHub repository where all of the work is published as it's created. And so those three things, that's like the three-legged stool of many open source teams. You usually have like a Discord or a Slack. You usually have an email list, and then you have GitHub or GitLab. So that would be the best way to learn about the technical details. So yeah, just getting started at our website, and you'll welcome aboard.
That would be great. It's probably also safe to say you could probably just Google search W5NYV and find 100 different ways to reach Michelle.
Yeah, and any comment, critique, feedback is welcome.
Any further questions? I don't see anything else coming. Oh, here we go. We have one more from Marcus here. Marcus, N5ZY, is the digitized voice used in SSB or FM or a different modulation mode I don't have in my ICOM radio?
The digitized voice for the uplink is called Opulent Voice, and it's 4FSK. It's probably not going to be on your ICOM radio as straightforward as other modes. But our goal is to provide ground equipment and transmit equipment, that we would like to see this mode used terrestrially as well as for the uplink. That's the only real way. You have to provide designs that are very easy for people to use, duplicate, to get running. So there's a presentation about Opulent Voice here at Ham Expo that goes into some detail about the motivations and the differences and similarities between the modulations and coding that you may be familiar with. And we've also talked about, this is a sort of, I would call it kind of a stretch goal. So we do have a native digital uplink. And the downlink is DVB-S2, S2X. There are a growing number of receivers, either software-defined based or hardware solutions for these that are in progress. So we're helping at least one of those teams with a receiver to add DVB-S2 and S2X to it. So what we really would like is to have the ability for you to use ordinary analog communications in your particular channel as well. So we've talked about a number of ways to do this, and we would really like to have more discussion about it, that the payload, the spacecraft, can recognize if you are transmitting a high bit rate, voice, Opus encoder for Opulent Voice. And there are some things that it can do with that it can't do with just a sampled analog signal, but there's nothing stopping us from just simply passing along analog voice and putting it into the multiplexed downlink. So this is something that we've talked about and we want to do because it makes the widest variety of equipment useful for this and not restrict it to some particular fancy new digital mode. So it's something I'm very sensitive to, is that we really need to go above and beyond and make it possible for as many different types of communications to go through this communications resource as possible. And the limit is, well, can you still can you close the link? Is there enough processing time to do it? The feasibility of it. We need to demonstrate this in a full prototype, end-to-end prototype, and that's kind of where we're at right now. The downlink encoder is pretty solid. The uplink receiver for opulent voice has started development, and then all the multiplexing stuff and the firmware started. So parts of this whole system are working. The whole end-to-end demo that we really want to show off, not quite there yet, rapidly getting that way. And as soon as that is demonstrated, because I believe that it doesn't work until it works over the air, then I think the very next thing would be, okay, so let's turn off the fancy digital uplink and let's see what we can do with passing through a signal that is recognized as a signal. The advantage to the digital uplink is that you get authentication and authorization, and that you are for sure that you have an amateur signal. And if you allow anything to pass through the repeater in space, then, well, this opens up a lot of noise, potential negative, uses of it. And so we kind of like the digital side of it, that it gives us some authentication and authorization, and it enforces kind of like this is an amateur radio resource, and that amateurs are using it efficiently and well. So those are all the different aspects of trying to decide how to support a diversity of communications modes. It needs to be done thoughtfully and well, and we need to not shut anybody out unnecessarily. So I hope that gives you at least a little bit of reassurance that it's something that is in the front of our minds, and that it's a goal to demonstrate as wide and as inclusive communications resource as possible.
Okay, and we have another question from Peter G0ABI. You mentioned QO100. Have you got a working relationship with AMSAT German?
Yes, in a variety of ways. I'm very fortunate to be able to talk with Peter Gultso ever so often, and he's been extremely helpful and supportive and given me really good advice. And several AMSAT DL volunteers have helped us from time to time with either GMAT, orbital stuff, and the calculations that we have that we're working with right now come from an AMSAT DL volunteer. So that's the type of relationship that we really want to see. We want to be able to work with international organizations like this, and fortunately, we now have the regulatory tools to ensure that that's safe, as long as you are using open source, the open source carve-outs in ITAR and EAR from the US perspective, and publishing everything as it's created, then you are much, much safer. And you can have conversations about satellite design and communications, and you can solve problems with international folks like AMSAT DL, who excellent resource, fantastic people, and look forward to continuing to work with them.
Yes, I can certainly see great advantages there, especially since AMSAT DL has some good hardware solutions for QO100 already. So interfacing that to other things certainly open the opportunities much quicker. So very good.
I mean, already you can get used to your own thing, and the in the workshops for this particular proposal, it was a JAMSAT member that made the suggestion that, the frequencies for QO100, you really should consider that very strongly, to reuse all of this excellent engineering on the ground, all of these amazing designs and activity. It would just be simply silly to not consider including it, to go ahead and include it. So that was a fantastic suggestion, and that's why it's part of the discussion now. to try to figure out exactly how to leverage all this wonderful activity from QO 100.
Mm-hmm. Okay, any further questions from the crowd here? I don't see anything else coming in. I certainly want to thank everybody for joining us today. I will turn it over to you, Michelle, for any final closing comments.
Oh, well, thank you so much. I think that the one thing that I'd like to close with is a lot of this, like digital microwave broadband technology, and especially using FPGAs, can be it's advanced work, and it can be specialized. There's not a whole lot of people out there that both have communications experience, especially amateur communications, and also are good at FPGA design. So yes, there's a lot of difficult work here, but our mission is to make this understandable, make it accessible, and to break it down, and to show that we can get traction on it. So we really do invite anybody with an interest to go ahead and just dive in, and we'll do our very best to make any aspect of this something that at least you get learning out of. And we invite you to go ahead and join up and take a crack and look at the things that we published. Your feedback and your comments are the fuel for working hard. And if you are interested in digging into some of the more steep learning curve aspects of this, we are here to help you do that. So that's the one thing I'd like to emphasize, is that that's part of our mission, is to make these what often are only really found in proprietary designs, to open them up, open source them, and make them accessible to the amateur community, because we deserve to know about this stuff. And I think that we should become competent as much as we can, and that's part of our mission.
Fantastic. Very good. Thank you so much, Michelle. I know I certainly appreciate it. I'm certain everyone else has as well. So look forward to seeing you throughout the rest of the QSO Today conference here. So wonderful. See you again soon. And thank you all for attending.